couldn't find a youth and but I already applied for the UA and I didn't need to use my
Well, you don't have to use contact like that either. I would put it if you're applying all these schools. Makes it yeah, I know. And when I forward this to school, it's like, they really tell you something about it. I was like, I think I'm just gonna go here just because I want to vlog. Yeah, it's so freaking awesome. I just can't give myself the deadline. That's exactly right. It's just an exactly, and everyone's getting the same grade. It's like, oh, I can't.
Yep. You get tickets. Did I get tickets? I didn't even try.
Don't forget y'all's hangups.
I got tickets. How many? $240 a piece.
$240 a piece?
Yeah. Because he's doing it through Ticketmaster. He gave up. That's like the cheapest too.
I mean,
The cheapest ones were 200.
I think it's worth it.
Oh yeah, for 200.
The way he did it last year sucked.
Yeah.
It was so bad.
Well, I mean, but 65 is that. Weren't that like $60?
Yeah, but it's so hard to actually get on the website to buy the tickets,
but,
even
yeah.
if you got selected. That's why
For
it's
Chris
everything else.
Stapleton, we got like the good seats for like $460 a piece.
Yeah.
So it's still pretty.
Who else in here? Is Jacob?
Yeah.
I am in here.
You ready, Jack?
No.
You ready? About knocked it out.
I think it was like 90 minus.
That's what I'm saying. That's on the quiz.
That sounds mean. I didn't mean that to be mean.
I didn't thought it.
Jacob. Tyler. I need y'all to clear your desk off for our memorization quiz. If you turned in your phone, that's fine. I'm not requiring that you turn in your phone, but make sure you have it put away. Don't leave it on your desk or something where you might grab it. Also, if there's no calculator, I don't know how a calculator would help you. Matching, fill in the blank. All of it is exactly as I had forewarned you. So all 1 point apiece. So no partial credit. And now that everybody has it, make sure your name's on it. And you should probably number it as 14. I suggest you double check it before you turn it in. Can't give you all day on it or anything. Again, it's just memorization, so you either know it or you don't. But I would double check it before you turn it in. Bless you. as you guys finish, just find something quiet to work on for a minute. Give everybody time to work in peace. Oh, also, if you did turn in your phone, of course, pick it back up once I have your quiz. I don't need to keep it. I generally only ask for your phones on big quizzes and tests, though. Is anybody still working? I'll try to get the rest of those put in gradebook. For the end of today. But there was 2 new handouts, so if you forgot to pick those up or if you forgot to get your phone back, please go get that right away. One of these, I guess before we dive into the worksheet, I tried to help you out if you were paying attention to the daily meme. Do y'all understand this bottom one? What is sine over cosine? So if we just said tan of k, tan k, tank. Do you guys understand this one yet? Okay, how come it's sync? I mean, I know you know what a sync is, but why is this sync? Okay, if tangent sine over cosine times by cosine divide by cosine leaves sine, or sin k, sync. I thought that was pretty clever. Y'all are hard to impress. Okay, that's actually, that top one is what we are going to be looking at with some trig proofs. So the reason why, you may not feel the same way, but we feel like we're giving you the opportunity for an easy quiz that you just took, because all you had to do is memorize that stuff, is this stuff is going to carry over into this. And in my opinion, I think trig proofs are probably the hardest thing we have to do all year. And what makes them difficult is you have to have the basics memorized, like hopefully you do now. And there's not just certain steps to take. I can't say do this for step 1 and then always do this for step 2 and then always do this for step 3 and you get your answer. We have to be a little bit more creative. So you've got 2 handouts because we're going to start off with this one, the beginner level one. So they start off a little bit easier and then allows us to kind of work up to where we need you to be. But the idea of the trig proof is to show that the left side and the right side are equal. These are not true-false questions. We're telling you all of these are true, but none of these are considered basic identities. We don't use these enough that we bother memorizing them, but if we have the basics memorized, then we should be able to see that this is true and show that it's true. So what you have to do is you just have to think of some way to rewrite this stuff so that you can make the left side and the right side say the same thing. Now, before we get too deep into this, the most common mistake that will automatically make your whole problem wrong is if you add, subtract, multiply, or divide to both sides of the equation. That is wrong. We're not solving an equation here. We're trying to show that one side is the same as the other side. So typically, pick a side and leave it alone. Whatever side looks basic or more basic, just leave it alone until you make the other side look like that. Now, you got to think of some ways to rewrite this stuff. So instead of saying tangent, what could we say instead of tangent? Okay, so maybe sine over cosine. And if you only think to make that substitution, this is where these problems can be kind of frustrating. You make that substitution and it's true, it just doesn't help. Or not yet. But what could we say instead of cotangent? Okay, you could put 1 over tangent, which unfortunately doesn't help. It's not that it's wrong, it's just not what we need. What else did I hear? Okay, so it could also be cosine over sine. And then you've got a times cosine divide cosine, and it's times sine divide by sine. And so I show that the left side is in fact the same thing as 1. Again, I'm not trying to show that it's true or false. I'm trying to show that it's true. All of these are understood to be true things. And I'm glad you guys threw out some of those other answers, because even though cotangent's 1 over tangent, sometimes you want that, sometimes you want cosine over sine. We need to be able to think of it as both ways. All right, what about question 2? What would you maybe be able to rewrite in this mess? Okay, secant is the same as 1 over cosine. So we're just going to try it, and if it works, great. If it doesn't, worst case, we erase it and try something different. And then we can see times cosine divided by cosine. So the left side is equal to the right side. Okay, this one's kind of that sink meme. Instead of saying tangent, we could say 1 over cotangent, or we could say what?
Sine over cosine.
Could be sine over cosine. So you try it. You see cosine divided by cosine cancels out and leaves you a sine, which is what I needed. Notice how I'm leaving the right side alone. I'm never adding something to the right side, multiplying something to the right side. I'm going to use algebra and trig identities to make the left side look different until I make it look like the right side. Okay, and it could be x, it could be theta, it could be t. There's lots of different ways to talk about angles. It could be capital A, but same thing. So there's not too much you can do with sine, but instead of saying cotangent, you could try 1 over tangent. There's nothing wrong with trying that. It's just that you're going to hit a wall. This doesn't cancel to give you cosine, or at least not yet. So you have to go back and try a different algebra thing, or maybe a different trig identity. Maybe try cosine over sine. Then those cancel, and then it's been proven. So pretty much everything in trig is connected in some way. And again, there's just tons and tons of relationships like these that we just can't bother to be memorized. There's too many of them. So we need to be able to do this. Okay, what I want you to get out of question 5 is, as a last resort, this is something that always works, but if you do it too early, you're going to make some questions harder than they need to be. But as a last resort, one of the best tools I can give you is just change everything into sines and cosines. Change this guy into terms of sines and cosines. Take this guy in terms of sines and cosines. And this guy's already in terms of sine. And again, if you just always do that, even though mathematically it is a way to always do it, you will make some questions really, really hard. So try to save that for when you don't know what else to do. But now that I've got everything in terms of sines and cosines, I can see that the cosines cancel and reduce, the sines cancel and reduce, and now the left side equals the right side. All right, now we're going to bump up the difficulty a little bit. So let's make sure that we realize what tools we're using, because these are going to carry over as well. Question 1, we used quotient identities. Question 2, we used the reciprocal identity. Question 3, we used the quotient identity. Question 4, a quotient identity. Question 5, we turned everything in terms of sines and cosines. Sometimes that's reciprocal identity, sometimes that's quotient identity. None of that's going to help with number 6 though. But when you see these parentheses like this, when you saw those in algebra class, what do you normally do with this? Okay, multiply them. And what is it called if you do 2 terms times 2 terms? Right, most teachers call it FOIL. So I don't know 100% sure that I should FOIL, but if I don't know what else to do, I don't see any trig identities to replace, we can FOIL these. Also, these questions are very difficult to just look at and predict what all the steps are going to look like before you start. Generally, you just have to try something, put it on paper. If it works, great, and if it doesn't, erase it and try something else. But we tried that, and then what looks like we should do next? Okay, these are just going to add to 0. And then finally, somehow we're supposed to show 1 minus sine squared is the same thing as cosine squared. Any guesses how these two are related? All right, so what I usually recommend for students is at the top of your page, just do it one time carefully. We have our 3 Pythagorean identities. You've got sine squared plus cosine squared is 1. You could divide all of those by sine squared or all of them by cosine squared. If you do that one time at the top of your paper so you have those to visualize, then I think that will help. Now, I know what I want you to do is I want you to see this is very similar to this that you should now have memorized. I know there's a temptation to add the sine squared over, but again, we're not solving equations. We can't do that. But what we can do is we can visualize that with this. These basic identities we don't have to prove. So can you see in this, if I subtract this sine squared over, that it would be equal to cosine squared? You see how if I manipulate this, 1 minus sine squared is cosine squared? Yes? Okay. Then that means 1 minus sine squared is the same thing as cosine squared. And because that's a basic identity, I don't have to prove why that's true. You just have to know these identities well enough that you can recognize them. But that's the first question where you see FOIL can help, and it's the first question where you can see the 3 Pythagorean identities can show up. Okay, so again, question 7. Looks like this should probably be FOILed. I don't know for sure, but go ahead and try it. I mean, I guess I do know for sure because I've done this worksheet a bunch, but you could try to FOIL, see what you've got. If you see some stuff cancels out, go ahead and cancel them out, see what you got left over. And then on the top of your page, if you have this written down so that you can quickly glance at it, 1 minus cosine squared is always equal to sine squared. So in place of 1 minus cosine squared, we can just throw in a sine squared. Again, this is considered a basic identity, so you don't have to prove why this is equal to this. You just have to know the identity well enough to recognize it and plug it in. Okay, good to keep going? Okay. All right, and then one more. Sure looks like it needs to be FOILed, so let's go ahead and try to FOIL it. Some stuff cancels. You're left with secant squared minus tangent squared is 1. If you're not careful, you might change this in terms of cosines, 1 over cosine squared. You might change this in terms of sines and cosines. That would be sine squared over cosine squared. You could add those fractions together. They already have a common denominator. And you can eventually prove that this equals 1. But if you're paying attention, and you have this written at the top of your page, it's a whole lot easier to see that. Let's see, divide them all by cosine squared. It looks like secant squared minus tangent squared is really just 1. I don't have to prove why that's true because this is coming from this basic identity that we memorize. Again, I just think that visual at the top of your page for you to glance at makes it a little bit easier to see that you can make that substitution. Okay, so another kind of recap. First few questions we used quotient identities, reciprocal identities. We changed everything to sines and cosines. We did some FOILing, and we did some Pythagorean identities. So all of those things are things we need to consider on later questions when we get stuck. But slowly bumping up the difficulty here. Question 9 is a little bit unique, but we ask you to do something like this. And what I notice about question 9 is that I've got some sine squareds and some cosine squareds, but I only want sines. I only want sine squareds. So I might want to leave this alone. He's probably fine. I need sine squareds. But I know this cosine squareds need to go away. So I've got to think of some way to write cosine squareds in terms of sine squareds. So first Pythagorean identity, if I solve this for cosine squared is the same thing as 1 minus sine squared. So instead of cosine squared, we can do 1 minus sine squared. And again, that's not obvious to people. I'm trying to show you how I see that. I see what I have versus what I want, and that gives me a hint about what needs to change. So manipulating this a little bit tells me how this changes. This is the same as this. And if you think to do that, then you're probably in good shape, because you could distribute the negative, combine your like terms. This is how you get 2 of these. And now the left side is the same as the right side. This side that you guys are keeping the same, you're welcome to copy it down every single step, but if you leave it blank like this, it's implied that you're just carrying it down. So okay, you guys see how I made this switch and why I made this switch? So it's not like we're going to use this often, but 10 questions from now, if you see that you've got sines and cosines on the left but only sines on the right, that gives you a hint about what you need to try to change. Okay, what I notice about question 10 to give me a hint on how to move forward is question 10 has 2 terms on the left but 1 big term on the right. So if I can figure out some way to push these together so that it's 1 big term, it might look closer to this. So right now, the left is sine over cosine plus cosine over sine. And so the algebra step that we need here that we've not needed for other questions is, in order for me to push these 2 together, in order to add these fractions together, I need a common denominator. So this guy has a cosine, this side has a sine. So he needs a sine, but you can't just multiply the denominator by sine without multiplying the numerator by sine. That's like you're essentially multiplying by 1. This guy is missing a cosine. If you multiply his denominator by cosine, you have to multiply his numerator by cosine. And the point of giving a common denominator is that we can push this all together as 1 big fraction. Sine times sine is sine squared. Cosine times cosine is cosine squared. And what does sine squared plus cosine squared always equal? Okay, first Pythagorean identity. And then finally, 1 over sine, we can change to cosecant. That's a reciprocal identity. 1 over cosine is secant, which is also a reciprocal identity. Now the left and the right say the same thing. So again, you don't have to add fractions often, but there will be a few questions where you need to add fractions like this. So the reason why I thought about adding fractions is 2 terms on the left but 1 term on the right. I knew if I added these fractions together, it would make it 1 term, which I thought would be an improvement. Of course, to add fractions, you need to get a common denominator though. So, okay, anything that jumps out at you about 10 you want to speak up? Yeah.
Could you repeat what you do after you get the sine squared plus cosine squared over the cosine inside?
Okay, well,
After that part?
this is just equal to 1. That's the first Pythagorean identity. That one we just have memorized. So if you have it memorized, you can substitute in 1. And then for this, I just said 1 over sine is cosecant, reciprocal identity, and 1 over cosine is secant, also reciprocal identity. This is why we push you guys to memorize those before this class, because the more comfortable you are with all of those identities, the easier it is to see what you need to do. Okay, and then another big skill, although you could work this one multiple ways. In fact, a lot of these you could work multiple ways. But you should know that it is fine to split apart a fraction if you're only splitting apart the numerator. So I can put this over the denominator as long as I put this over the denominator. You can't split apart denominators that way, but you can split apart numerators that way. And you're going to see that this is a pretty common, it makes some questions easier to do it this way. On the far left, you're left with something divided by itself, which would be 1. Over here, this is a reciprocal identity, which is cosine squared. And for already about the 5th time this period, this looks like a version of the first Pythagorean identity. So we glance at this at the top of your page. 1 minus cosine squared is the same thing as sine squared. Now, let me give you this warning, because I give this warning every year, and students still do this. If, on a quiz or a test, you get something like this, and you don't write this last step, I can't give you full points for this. To me, it looks like you got to here, and you didn't realize 1 minus cosine squared was the same thing as sine squared. To really finish, you need the left side and the right side to say the exact same thing. And I hate to do that because I think you usually know, but I can only grade what you put down. Okay, and then one more I want us to learn from here, and then it'll be a little bit more mixed up on the next one. So in the last question, I said splitting apart your fraction can be a good idea. So let's try to put tangent b over tangent b plus cotangent b over tangent b. And then tangent divided by tangent is going to be 1. Anything divided by itself is 1. Somehow this is supposed to come out to be cosecant. Now, if you're looking at your Pythagorean identities at the top of your page, you can maybe get a hint. The one that has cosecant looks like this. So, can you guess what this is going to come out to be? What do you think it's going to be? Not sine squared. Right. Look at this. 1 plus what gives you cosecant squared. This is 1 plus what gives you cosecant squared. The reason why you can't just say, well, okay, that's a little bit of a lie. You can't just say this, because this is not a basic identity. We didn't ask you to memorize that cotangent divided by tangent is cotangent squared. If it's not a basic identity, you should not be using it. So, worst case, and then I'll show you a smarter way, which kind of breaks what I said. But if you're not sure how, you know this is supposed to come out to be cotangent squared, but you're not sure how to show it, last case is change this stuff into sines and cosines. So instead of saying cotangent, say cosine over sine. A fraction bar just means divide. And instead of saying tangent, do sine over cosine. To divide fractions is the same as multiplying by the reciprocal. So we end up with 1 plus cosine squared over sine squared. And what is cosine squared over sine squared? cotangent squared, which is what I knew it was supposed to be. But again, the point of these questions is not for you to figure out if they're true or not. The point of these questions is for you to write down enough evidence that you have shown that they're the same. Now, the smarter approach to this, which is also completely fair game, but instead of doing all of this, I told you changing things in the sines and cosines always works, but sometimes it's really messy, is right here, we could have sidetracked and said, tangent divided by tangent is 1. And then let me phrase this very carefully. It's the same as this, but we can skip some steps if we're paying attention. Cotangent divided by tangent is the same thing as cotangent times what? Right. Dividing by something is the same thing as multiplying by its reciprocal. That's what you're doing right here. Dividing by something is the same as multiplying by its reciprocal. So dividing by tangent is really the same thing as multiplying by cotangent. And you can see that that would have been a lot faster way to finish the question than to do all of that. But both are fine. Both would get you full points. Mathematically, we always try to aim for the most efficient. For your sanity, you want to aim for the most efficient. But if you don't catch it and you have to turn things into sines and cosines, as long as you can do it, it's okay. All right, before we slide on to the next worksheet, where it's not going to ramp up in difficulty, it's kind of scrambled up, let's just make sure that we have a list of things that we've tried and have worked. Quotient identities, reciprocal identities, quotient identities, change everything into sines and cosines there. FOIL, Pythagorean identities, FOIL, Pythagorean identities, FOIL, Pythagorean identities. The top right, looking at what we had versus what we needed to know what to change. Number 10, seeing two terms could be one term if we added those fractions together, getting a common denominator. Number 11, splitting apart your numerator into two separate fractions and Pythagorean identities. Number 12, splitting apart your numerator into two separate fractions, and then maybe changing everything into sines and cosines, or just being very careful about dividing by something is the same as multiplying by its reciprocal. So none of the questions on the next handout are going to be the same as these, but it's going to be similar skills. So let's look at see, we're 5th. Okay, so truthfully, if you just sit here and watch me do them all, it's a little bit easier to think that you're on the right track. But until you try a question and struggle and realize that you may not know a strategy to move forward, that's really what you need for your learning. So I'm going to give you 2 minutes to look at question 1 and try it out. And then we'll go over it. So I'll help you get unstuck if you get stuck. Again, there's more than one way to do these questions, but there's usually one way that's quite a bit easier. And if you don't know how to start, think about all the things I just rattled off on the other worksheet. Is there a trig identity? Can you FOIL? Can you add your fractions? What else did we try? And that gives you a hint about what to do. way more than enough time, but again, you do have to kind of slow down and think about what you're doing at first. So, to spare you guys from me explaining every single question, can somebody tell us what they think a good first step might be? What you got? Go ahead and just call it out, it's fine.
Split the numerator into 1 over cosine, cosine, cosine.
Very good. I think that's probably the most efficient path. So again, we did that on the other worksheet, and I tried to say it without saying it. But if you tried that, this obviously becomes 1. Anything divided by itself is 1. You peek over to the right, you're supposed to have a plus 1 there, so that looks good. And then 1 over cosine is secant, which is great because that's what I needed over here as well. Left side is the same as the right side. That's all that's needed. Now, I'm not saying that there's not some other way to do that, but you're not going to do it in less than 2 steps. So if you didn't think to split apart your fraction on this one, after we just did that successfully on a couple questions on the other worksheet, you need to write that down or consider it every single question. When you start question 2, see if you can split apart the fraction. When you look at question 3, see if you can split apart the fraction. Consider that as one of your tools that you can do. Okay, same thing, so let me give, let's say 2 minutes for you to try question 2 and see how far you can get. Now again, there's more than one way to do these, and honestly you should kind of know if your answer is right. As long as you're not making up some trig identity that's not a real trig identity, or you're like adding fractions in a way they don't really add, you're not just making up some math. If you're consistent with your math and your trig identities and you make the left side say the right side, then yours is correct, and you don't have to wait for us to go over it. You can try a different question. But we'll do a couple more like this guided practice, and then I'll ask you to do most of the questions on the front page and a few questions on the back page. And that will be class for today. Already 2 minutes. So, somebody want to tell us what you thought the first step should be? Sorry, you said separate? Okay. So once again, if it worked in question 1, doesn't mean it's guaranteed to work in question 2, but might as well try it. Okay, so you did that. And again, if you're expecting to say, okay, I'm going to split this up and then I'm going to do this, and you wait till you think you can visualize the whole process before you put pencil to paper, that's a mistake. Some of these questions are too long to do that. If splitting it apart works sometimes, split it apart and then reevaluate. If it looks like you're going in the right direction, this is 1, this is sine squared. If it looks like you're going in the right direction, stay there. And if it doesn't, erase and try a different approach. And then what can I put in place of 1 minus sine squared? Okay, and I don't have to prove that because that is one of the basic identities that we memorize. So, new worksheet, So once again, I think it's in your benefit to write out the 3 Pythagorean identities at the top to visualize. If you know this one, divide them all by sine squared to get another one. Divide them all by cosine squared to get the third one. Then you can see 1 minus sine squared is the same as cosine squared. You can just make that substitution. Once again, I don't know why this is such a thing. Don't stop here. If you stop here, it looks like you don't know 1 minus sine squared is cosine squared. You need that last line. Okay, I'd like to do one more as guided practice, and then I will tell you which ones I'd like you to do. So try question 3, please. Same thing, I give you just a few minutes. Okay, so partly I wanted you to try this one to see if you fell into this trap. If question 1, separating the fractions worked out, and then question 2, separating the fractions worked out, then maybe you thought to separate the fractions here. But you can't split apart denominators, only numerators. So I'll give you a quick example with some numbers that helps you see that. If I did like this, the real answer to this is 4 over 4, which would be 1. That's the correct answer. If you split apart your numerator, it's the same thing as 3/4 plus 1/4, which is still 1. So you get 1 either way. But if I switch that and make it like this, the real answer to this should be 1, because you've got 4 over 4. But if you try to split apart your denominator, you're going to think this is the same thing as 4/3 plus 4, which would be like 5 1/3, which is far away from 1. You can split apart numerators, but not denominators. So it's fine to think that that's a good way to start, but you should stop yourself. Okay, and then you're looking at the rest of this, and then hopefully, we've seen this about 5, 6, 7, 8 times at this point. What is 1 minus sine squared equal to?
Secant squared.
Close, not secant.
Cosine.
Cosine squared. the first Pythagorean identity. So, if after a moment or a minute or two you finally think to make that substitution, then this should be a little more clear that this is tangent squared. And then if you take my advice and have your Pythagorean identities written up top, you're going to see that you're almost done. Because one of them should look like this. And so tangent squared is the same thing as secant squared minus 1. That's a basic identity. I don't have to prove why that's true. I just have to recognize, based on what I wanted and what I had, that it was a basic identity I had memorized. So once again, that's not the only way to do that question. So if you did something else and you're not sure if it's right, you probably need to have me look at it and double check. But all right, what I'd like you guys to do is, for the rest of class, I'd like you to try the rest of the questions on the front page first, except for question 8. If I remember right, question 8 is, I think it's the hardest one on the worksheet. So do these 4 first, and you're welcome to work within your little groups and compare and help each other out, and I'll be coming around to help as well. But do those 4 first, and then once you've got those 4 done, try to do a few of them on the back. You can pick and choose. So feel free to pick out the ones that look like they would be the easiest. If you get stuck on 4, 5, 6, or 7, I want to make sure that we get all that cleared up for you. And I guess I'll give you a few minutes to work before I come around to help. It might not be a terrible idea if you had your 4.3 notes out to see the back page. Again, you need to really have those memorized, but it might be helpful to have that to glance at. I'll leave that up to you. Science on technically is one other science, so you can't make that change. So, what I would probably do, like this one, this has 2 turners, but that side has 1 turn. This side has 2 turners, but that side has 1 turn. I would try to get these to have a common denominator and try to add those fractions. As I come around, if you need a hint, please let me know. Let's see, change that, which cancels that. Do that, so the same as that, yep, works. But it looks like you're canceling out the cosines. Those aren't going to cancel out because you got a cosine times a cosine. They'd only cancel out if it was cosine divided by cosine. So don't cancel those out. To me, it's a little bit like this one. You've got 2 fractions on the left, but only 1 term on the right. So get a common denominator and try to add them together. Again, I'm only giving hints here. I'm not trying to do the whole thing for you.
I just did remember 6.
Well, I wish you hadn't erased your stuff. What did you have down before you erased it?
I like did sine of the 1,
Okay.
and cosine of the 1, and then flip them so then I'll get caught. Cotangent.
Okay. Did you put anything in place of cotangent?
What?
Did you change anything in the cotangent?
No.
Alright, well, cotangent is cosine over sine. So you could change, make that change.
Because I know these two, like, these two equal. Cotangent.
Sine plus cosine doesn't give anything. Sine squared plus cosine squared gives 1, but sine plus cosine doesn't give anything. If you change this to cosine over sine, you can multiply that cosine, and that gives you cosine squared over sine. Well, what I see is you've got two fractions, sine over 1, and you're going to have a fraction here as well. So two fractions on the left, just like there's two fractions on the left. One term on the right. So try to get a common denominator and see if you can squeeze it together. What happened to your sign? You need to. Okay. But you need to keep up with your sign now. You still need a sign plus. Right. So when we write this is called vertical format. When you write this on top of this, on top of this, we're really saying this is equal to this is equal to this. So if you don't write the sign, it's not correct. That's why. Okay, so you can multiply these two fractions together, and you get cosine squared over sine. Okay, good. Go ahead and put your sign out front too. Oh, you wrote it on the right side, that's okay. Okay, so get a common denominator, it's a good idea. Yeah? Well, what's cosine squared plus sine squared always equal to? Okay. And then you're done. You wanted 1 over sine, you've got 1 over sine. You just need to make sure your work shows how you got to that. But you did all the right thinking.
Did I like show this one?
Number 6.
Yeah, that's what confused me. It's like.
I don't like how this disappeared at first. Like I see you doing this is this,
Yeah.
and then this multiplied is the same as that. And then it's like later on you're worrying about this. So that's the only thing I don't like about that.
So like
Put a plus sign out front. Okay, and then I can see you went here's there, you put that on the back end, common denominator. Yeah, that's fine. That's enough. Did all this on the front, so I just number 8. Nothing? Yeah. Get on the front then? Yep. Okay. Do a few on the back. Again, do all of them on the front except for 8, and then do a few on the back. The more of them that you get down on the back, the less homework you'll have, less classwork you'll have next time. So you don't have to have it all finished by next time. But
Number 6. Just a little stuff.
okay, well, this is true, but if you got stuff, you gotta try something else. So my go-to is change everything to sines and cosines. For every sine or for every cosine, but this guy should be. And then since nothing else seems obvious. Go ahead. Guess what would stand up to me next would be, so you can multiply these together. So you've got two terms here, fraction, you can put this over 1 plus a fraction. And on this side, you've just got 1 fraction. So it's continuous difference. You've got 2 fractions and you need to combine them to 1 big fraction. try to get a common denominator and see if you can make that work out.
Okay.
You have the first ones then? After you do those 4 on the front, if you really want a challenge, you could do the 8. But again, 8 is the hardest one, I think, so I would save it to the very end. I would say erase these parts, which is in there, getting further away. You're almost done.
Yeah, I figured I was just gonna put this.
You could, but there's no need to, because what's sine squared plus cosine squared?
Oh, it's just one.
So there you go. That's, you were right there. You were almost making it harder. Got all the other 4 on the front. I'm just trying to figure out what like common issues you guys are having, so I know what to emphasize. You're almost there. What's sine squared plus cosine squared always equal to? Yeah, it looks like you're trying to cancel out these signs, but they're being added. You can only cancel it out if they're being multiplied. I'm gonna go over that one, so you're on the board. That's been the hardest one, it seems like. Because that's a basic identity, I know why you're so good at it. Any of the ones we ask you to memorize, you don't have to prove. You just plug them in. It's everything that comes from cosine, cosine. Messy, but alright. Okay, as long as you do it correctly and you do it correctly. Okay. Correct. Correct. All your reasoning looks good and that's what you want. I would say the only concern I have is I can follow what you're saying, but I have to go off of what you wrote down. So
Okay.
I couldn't give you full points on this because, like, let's see, here I'm with you. This is equal to this. But then from here, I would assume you're going here, so it doesn't look the same. So you need to show me, like, you could say this is 1 minus sign times 1 plus sign, but you need to put your data in there. I know what you're saying, but trick me. And if you put a parentheses here and a parentheses there, you got here, this, cancel those out, and then what? Okay, yeah,
I need
so,
to-
yeah, have this below it though,
Okay.
because if it's above, we do vertical format, so like, we just do it this way. So your last step shouldn't be on top of it.
Okay.
All your reasoning is good. You don't have to start with that one. I don't think that's one of the easier ones. When y'all get to the back, feel free to do any of them that you want. Start off with the easiest ones. I don't think number 9 is the easiest. Okay, well, what did you try? Okay. Okay, so let's write down what you got. You got sine. What happens when you multiply cosine times cotangent? to me, there's not too much obvious that we could do. But I do notice that this side has two fractions. You can put this over 1 if you want to look at this fraction. And that side has one fraction. So over here, when we did that, when we had two fractions and we wanted it to become one fraction, try to get a common denominator so you can squish those together. So multiply the top and the bottom of that by you got a common denominator, you can squish it together into one big fraction. Okay, now what happens to your numerator? What's sine squared plus cosine squared? And that's what you want it to be, right? So the hardest part of that is like if you're stuck considering adding your fractions. What was it? Well, it didn't ever hurt to try it. I don't know what I would do to move on from it there. Maybe instead of doing 1 over tangent here, maybe try cosine over sine. Because putting everything in terms of sines, cosines, in theory always works. Copy the sine down too. Now, a lot of people are getting stuck here, but what I noticed is you've got two fractions on the left. You can always put this over 1, and only one fraction on the right. So over here, when we have two fractions, one way to get it to be one big fraction is to try to get a common denominator and squish those together. So. Erase that. You're close. Erase this last step. To get them, there'd be a common denominator. This guy's a sine. This guy's a 1. So the least common denominator is going to be sine. So you really want to multiply this denominator by sine, and then you have to multiply the numerator by sine too. So it's going to make it sine squared over sine. I'm not doing anything with that yet. But the point of getting a common denominator like this is once you get a common denominator, you can now push those together. So you're going to get sine squared theta plus cosine squared theta. It's all over sine theta. Okay. And what's sine squared plus cosine squared? And that's what you need to do. Okay, to try to help out here, I'm going to go over those 4 questions I asked you to do on the front page. And again, you have a good idea if you did those correctly, so you really only have to pay attention to the ones that you struggled with. I'd say even if you feel like you got it right, if it felt terribly inefficient, you might still want to follow along. But so what I would do with question 4, there were several questions where splitting apart our fraction worked. So I would try to split apart my fraction in 4. Again, you never 100% know if that's a good idea until you're finished. But if you do that, then secant divided by secant would be 1, which is a good sign because I needed a -1 and I've got a -1. I guess one thing I would be concerned about is you can peek ahead and see that this is supposed to be cotangent. So this stuff is supposed to be cotangent. But if you did this to get question 4, this doesn't, I can't give you full points for this. because we didn't memorize that cosecant divided by secant is cotangent. That's not a basic identity. You can peek to the right and it makes sense for you to see why it's going to land on cotangent in the end, but you can't go straight to cotangent. You have to show me what you're doing. So if nothing else, change these to sines and cosines. So instead of saying cosecant, you could do 1 over sine. A fraction bar just means division. Instead of saying secant, we could do 1 over cosine. To divide fractions, do keep, change, and flip. And then you end up with cosine over sine, which is cotangent. And then that would be sufficient. So I would say split apart your fractions to show that this mess comes out to be cotangent. If you take this shortcut and you don't show these steps, you won't get points for those steps. Again, the question isn't what does it come out to be. We're telling you what it comes out to be at the beginning. But to show it, change this in the sines, change this in the cosines, show how you divide fractions, and then you can show that it ends up being cotangent. Anybody that had issues with number 4 have any specific questions about it before I slide it away? Okay. And okay, even if you didn't need help with that one, make sure you didn't need help with 5 before I go on. So with 5, there's a couple things you could change. I would say probably the most efficient would be change everything to sines and cosines, because this is already in sines, this is already in cosines, and then one step away you could change this to cosines. Then these cancel, times cosine divided by cosine cancels. And then if you look at your first Pythagorean identity and manipulate it, sine squared is the same thing as 1 minus cosine squared. Make sure you show this last step though. If you don't show the last step, it looks like you got stuck. Your last step needs to be the stuff on the left is identical to the stuff on the right. Now, I didn't say this earlier, but by the way, if you would rather work with the right side instead of the left side, that is perfectly fine too. You really should work with whatever side looks most complicated. Okay, does anybody have any specific questions about number 5? Okay, then for those of you that needed help with number 6, this seemed to be the one that gave the most issues. So, no algebra skill jumps out at me, no trig identity jumps out at me, so before I call it quits, I would know to at least change everything into sines and cosines. Cotangent is cosine over sine. And then I guess I could say multiply these two, gives you cosine squared over sine. And then it's very likely that you might hesitate here, and that's okay. But one of the things we talked about on the other worksheet is if you've got 2 fractions on the left and only 1 fraction on the right, you might want to try to add these together with a common denominator. So to get these to be the same denominator, I need this guy to be sine. You can't multiply the denominator by sine without multiplying the numerator by sine. Multiplying the top and the bottom by sine is like multiplying by 1. And the point of getting a common denominator is so that you can push it together as one big fraction. And then this is the first Pythagorean identity. Sine squared plus cosine squared is 1. I'd say the hardest part of that though is this. Going from 2 terms to 1 term, not often, but sometimes you have to add fractions. So, a few questions from now, if you get stuck again, if you've got 2 terms but you want it to be 1 term, it might be that you need to add your fractions. Okay, I know I helped several people with that one, but is there any other specifics about it while it's still up there? Okay, and And then one more on the board is 7. And 7 can be one of the easier questions. 1 over secant is cosine. So 1 over secant squared would be cosine squared. And this is a form of the first Pythagorean identity. You don't have to prove why that's equal to sine squared. You just have to know it well enough to know that they're equal and to show it. So again, some of these can be as little as 2 steps, like question 7, or they can be as many steps as well, I guess question 6 was still only 4 steps. It just felt a lot harder. If I remember right, number 8 has like probably at least 7 or 8 steps, but we can look at that one together next time. Okay, any specifics about 7 before I throw that one away? You good with those? Okay. What do we got? All right, we've got just about 5 minutes, so maybe finish your thought on the question you're on. And just to be clear, we'll spend more class time on this next class. This is a harder skill. We spend more time on it. You do not have to do any of these for homework unless you want to. I kind of look at these as puzzles, so I like them. But if you don't want to do any of those for homework, you don't have time for it, then that's fine. But what I do need you to do for homework is this number 13, which was the bookwork from last class. We spent the whole class period on that, so you should be pretty close to finished with it. So please make sure between now and Friday, because this isn't a week, that you go back and try to finish the last questions you didn't have time to finish last class. And if there's any of those that you need help with, I've got every one of those worked out as videos on my website, so make sure you're utilizing that to get the help that you need. But make sure you have the book assignment done before I see you Friday.